rule needs to be used whenever you have a composite function. For example, a composite function that you had in chapter 2 test, like y equals absolute value of x plus 3. You could write this as g of x equals x plus 3, and f of x is equal to the absolute value of x, and that would have to go inside of the other. It's when a function is inside of another function, you have to use the chain rule. And here's the rule. This is a composite function when you put one inside the other. You take the derivative of the outside part of it, leave the inside alone, and then take the derivative of the inside. This is a two-linker. That's why it's called a chain, because of the links. I'll give you a 3-link one. This is a 3. The absolute value of the square root of x squared minus 3. G of x could be the absolute value of x. H of x could just be the x minus 3. And t of x could be the square root of x. You see that there's 3 different types of functions. You have the absolute value, you've got the square root, and then you've got your polynomial. This is called a 3-link. And that's why they call it the chain rule, because the bigger the link, the more work you need to do. So you need to recognize, like, the sign of x plus 3. It's usually the sign of x, but in place of the x, you did x plus 3, so that's a 2-linker. Okay, so how do you find the derivative of the first one? So this is the inside part. So you're going to leave that alone. This is the outside part. So you're going to put the 2 on the outside. You're going to leave the inside alone. You're going to change the power to a 1. So I only found the derivative of the outside part. But now I'm going to take the derivative of the inside part, which is 6x. They usually put this out in front with the 2. So the final answer is 12x, 3x squared plus 1. And they don't usually put those 2 together. Okay, the next one, y prime. You take the derivative of sine, and the derivative of sine is cosine. You leave the inside part alone, but then you take the derivative of the inside part, which is 3x squared plus 1, which equals, the 3x squared plus 1 usually goes in the front on the test, cosine of x cubed plus x. Because remember, it used to just be the sine of x, but you replace the sine of x with all of that, and that's why it's like that. Okay, the next one, I would rewrite this. This is a really important one. I would write this as the cosine of 5x minus 1. The whole thing is cubed. So the first 2 problems were 2-linkers. This is a 3-linker, and I'll tell you why it's a 3-linker, because you have a power of 3 is 1 link. Cosine is your second link, and the 5x minus 1 is your third link. So you have 3 links. You have 3 different functions in this problem. So to find the derivative, you take the derivative of the outside part, which is 3. You leave the inside alone. So that's why this changes to a 2, because I took the derivative of the outside part. Now I have to take the derivative of the inside part, but the inside part, you take the derivative of cosine, which is a negative sine. Again, you leave the inside alone, and then you take the derivative of the inside. And usually all of this goes out in front. So the final answer is y prime equals a negative 15 sine of 5x plus 1 with the cosine of 5x minus 1, all of that squared. and that's called a 3-linker. This one, see how many links you think this one is. I think the next one's only going to be a 2-linker. Nope, it's a 3-linker. Forget it's a 3-linker because I'm going to rewrite it. Oh, I'm just going to rewrite it. It's going to be 7 plus the sine of x squared, all of that cubed. See that 2 needs to get brought out all the way because it's all of that squared. So, to find the derivative, you take the 3, you leave the inside alone, change the power to a 2. Now take the derivative of the inside, and the derivative of 7 is 0. The derivative of the 2, leave the sign of x, make this a 1, and then take the derivative of the sign, which ends up being a cosine out here. So this is a 3-linker also. So y prime is equal to 3, not 3, it's equal to 3 times 2 is 6, sine of x, cosine of x, with the 7 plus the sine of x squared. Okay, the next ones. All we're doing is lots of examples so that you can get better at this. So this one, y equals x cosine of 4x raised to the 1/2 power. So y prime is equal to 1/2 x cosine of 4x to the negative 1/2. But then you also have to take the derivative of this, and the derivative of this is the product rule. So we're going to continue this. And this is x times the derivative of cosine, which is a negative sine of 4x times 4, plus the cosine of 4x times the derivative of x, which is 1. Final answer. Y prime for this one. The derivative of tangent, remember the derivative of tangent of x equals secant, let's make this, let's change, oh no, let's do this one. The derivative of tangent of x is secant squared x. So y prime equals the derivative of tangent is secant squared, leave the inside alone, and then take the derivative of the inside. The derivative of 5 is 0. The derivative of sine is a negative cosine of x. And then you also have to take the derivative, oh, I forgot the 2, sorry. That's a 2, that's a 2, and then you have to take the derivative of 2x, which is 2. So your final answer is y prime equals a negative 2 cosine of 2x times the secant squared of 5 minus the sine of 2x. Okay, number 7. This is y equals 2 over x plus 1 raised to the 1/2. So all I'm going to do is low d high minus high d low. I'm going to use the quotient rule. So the low times the derivative of the high minus the high times the derivative of the low, which is 1/2 x plus 1 to the negative 1/2. Find the derivative of that, which is 1. All over the square root of x plus 1 squared, which ends up becoming, this is 0, this makes 1, so this is going to be ending up being a negative x plus 1 to the negative 1/2 over the square root of x plus 1 squared, which ends up being a negative 1 over the square root of x plus 1 times the square root of x plus 1 squared, which is a negative 1 over the square root of x plus 1 raised to the 3/2 power. I don't need this. You can leave it like this too, or you can write it like this. It's up to you. The last problem, remember the derivative of cosecant of x? Remember the derivative of that is a negative cosecant of x, cotangent of x, but do you notice that that's an x? But look at the x is no longer an x anymore. The x is that huge thing. So when you do the derivative, you know it needs to be a negative cosecant of 5x squared minus 7x times the cotangent of 5x squared minus 7x times derivative of this, which is 10x minus 7. So this needs to be a negative 10x minus 7. Remember, it needed a negative sign in the front of it too. Find the tangent line to the curve y equals the sine of 5x at x equals pi over 3. So this would be a non-calculator one on the AP test. Again, they want you to find a tangent line. Y minus y equals mx minus x. X is pi over 3. And y is going to be the sine of pi over 3, all of that raised to the 5th power. So I come over here. The sine is the square root of 3 over 2 times itself 5 times. Which will give you 9 root 3 over 32. So that's what goes right there. 9 root 3 over 32 equals, and we need to know how to find the slope. So we're going to do y equals the sine of sine of x raised to the 5th. Y prime is equal to 5 sine of x to the 4th. I found the derivative of the outside, and now find the derivative of the inside. Put pi over 3 here and put pi over 3 here. The cosine is 1/2. And this is going to end up being the square root of 3 over 2 raised to the 4th. So y prime is going to equal 5. 9 over 16 and 1/2 will give you 45 over 32 is the slope. And do not simplify that. See how more complicated the problems are starting to get. Okay, the next one, 3 more problems. Show the slope of every line tangent to this curve will always be positive. Show the slope of every line tangent of the curve. So all I'm going to do is, if they're talking slopes, I'm going to find the derivative. So I'm just going to bring it up and make it a negative 3 instead. And now, whoops, that's just y. Now y prime is take the negative 3, put it out in front, go down by 1, so that's a negative 4. Take the derivative of the inside as a negative 2. So my slope is going to be a positive 6 on the top and 1 minus 2x to the 4th. On the AP test, you can explain that anything raised to the 4th power will be positive and a positive divided by a positive will always have a positive slope. Okay, looking at a chart, you have to know how to find the following. So find the derivatives. So I'll go nice and slow on how to read a chart. This is x, this is y, this is x, this is a different y, this is x, this is the slope of y, this is x, this is the slope of the other y, and your x will change from x from 2 to 3. So they want you to find the derivative of 2f of x. So the 2 just carries down, and the derivative of f of x is f prime of x. So at x equals 2. So f prime of x at x equals 2 is 1/3. So you're going to replace this with 1/3, and you're going to multiply it by 2. So your final answer is 2/3. Okay, f of x plus g of x. Again, you're finding the derivative. So the derivative of f of x is f prime of x. The derivative of g of x is g prime of x. And we're looking specifically at the 3, so we're looking down here. And the derivative at 3 is 2 pi, and the other one is 5, so the answer is 2 pi plus 5. Okay, now it's getting a little bit more difficult. You have to use the product rule. So you're going to do f of x times the derivative of g of x plus g of x times the derivative of f of x, and we're looking specifically at 3. So this is f of x, this is g of x, this is the slope of f of x, and this is the slope of g of x, which ends up being 15 minus 8 pi. You're going to have to know how to do this for the AP test. Okay, now this one is the composite. You take the derivative of the outside, you leave the inside alone, and then you're going to take the derivative of the inside. So you're going to do f prime of g of 2, and then you're going to do g prime of 2, and g prime of 2, this ends up being a -3. G of 2 is 2, so this is 2, and now we're doing f prime of 2, which is 1/3, and 1/3 of a -3 ends up being a -1. And the last part, the last set of notes. Okay, if they tell you to do this, and f of u is the square root of u plus 2u, and u is equal to the g of x, which is x plus 1 at x equals 3, then find f of g prime, or f of g of u. So if you see something like this on the test, and they say that u is equal to x plus 1, all I want you to do is to substitute right away before you find the derivative. So if f of u equals the square root of u plus 2u, I know I'm just rewriting it from up above, and I know that u is equal to x plus 1. This is what I want you to do. I want you to resubstitute in place of your u's. I need you to substitute. So you're going to get f of x equals the square root of x plus 1 plus 2 times x plus 1. I want you to substitute it in. After you substitute it in, now find the derivative, f prime of x. Oh, before we do f prime of x, though, let's rewrite it. This is f of x equals x plus 1 to the 1/2 power plus 2x plus 2. Now, let's find the derivative. F prime of x equals 1/2. Leave the inside alone. Change the power of 1/2 to a -1/2. Take the derivative of the inside, which is 1, plus the derivative of 2x is 2, and the derivative of 2 is 0. So this is the derivative, and then they want you to put 3 in. So f prime of x equals This is 1 over 2 root x plus 1 plus 2, and they want you to put 3 in, so you're going to put 3 in, and your final answer is going to equal 1 over 4 plus 2, which is the same thing as 2.25.